Hello, wonderful people of the internet, a silent tree. Hey, thanks for coming in. And anyone else who might be lurking in chat, hey, thanks for being here. So I didn't check the video and audio sync before stream, so there might be some delay between like when my mouth flaps open, my lips open, and the voice is actually heard on Twitch. If that's the case, I'll try to figure it out. I'm not really sure how to do that, but I'll try to figure it out live. A silent tree says it seems fine. Okay, couple quick notes to talk about before really going any further for today. The first of which is that there seems to be a what is it called when people, concert. There we go. There's something going on outside my window right now. I don't know what it is. It's some sort of event for Barcelona. Obviously, we wouldn't have rented this place had we known there would be so much noise so frequently, but I think it's just like a lot of stuff going on this week, so I don't know. I mean, like last Thursday there were fireworks that kind of kept us up a bit late. The day after that there were even more fireworks that were going on until about midnight. The day after that there was literally a band playing in a square very nearby until like 3 or 4 in the morning. Honestly, it was quite long. And then there was like a day of rest after that, and now it's today. Where there is definitely going to be a concert or something going on outside my window. I think it starts in about an hour and 30 minutes. I'm not really sure. So we're just going to see how the stream goes. If it ends up being that, at some point, I just don't play background music anymore because you can hear the music from outside. I really don't know how this is going to go. So we're just going to keep going until things get too ridiculous to keep going forward, and see how things go. I guess before continuing, also, this is not the time that I want to start streaming. I actually wanted to start streaming maybe 3 hours ago, but there were a bunch of little things that happened today that all kind of built on top of each other that made it so it was really difficult to stream until now. Like, for example, this morning so tomorrow is a holiday, but for some reason, everyone celebrates this entire weekend starting on Friday. So Friday, Saturday, Sunday, Monday, and Tuesday are all apparently holiday days. And so today, we went into the gym, but it was kind of sort of a holiday. And so we tried to sign up, but we couldn't, blah, 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 blah. Anyway, there was just a lot of little things that happened, and it just all built up into being, into me not being free until about now. So I'm streaming now. We're going to get as much done as we can and go from there. There's one other thing that I want to talk about before continuing, and that is this guy right here. So a lot of you guys have noticed, or I've mentioned to a lot of you guys, and a lot of you have mentioned back, that it would be really nice if we could have some sort of way in order to kind of consolidate all of the research community under something. I think it makes sense for them to be under the science and tech category, or the software and game development category, or even the just chatting category. I don't think the category matters so much, but I think having some sort of tag that people could kind of rally under would be quite nice, kind of like they do with programming or Linux or other things. It's just like, hey, this group of people is specifically doing research. That way, if I'm looking for a group of people, physicists, biologists, chemists, computer scientists, whatever, who are just kind of doing something new, pushing the boundary of human knowledge in some way, those are the type of people that I want to see under the research tag. So I recently just created this post here. I don't expect to get too much traction, but I just wanted to mention that if you can, I would really appreciate a vote on this particular thread, and even commenting on it, explaining why you may or may not want this category. All of that would be really, really helpful. One second, there's my water. I thought I left my water upstairs for a second. Let me drink a little bit. I mean, if we look at all of the ideas here, there are questions as to like whether these will actually be like looked at, and I don't really know the answer to that. But this is gonna be a tough stream. Let me just turn the music off now, because I just heard them playing stuff outside. So we're just gonna have to be without music, and this is gonna be interesting. Anyway, the point is the following. They've got a whole bunch of these ideas. Like the top idea is a no hit tag, which I think is kind of silly, but whatever. Then we have the make art creative its own directory, which is weird because it was its own directory for a while. Cybersecurity. Now, here's one that's quite interesting. I would like a cybersecurity category. There's a large number of cybersec streamers and even more followers. Currently, there's only 3 categories we stream under. Try Hack Me, Hack the Box, and Science and Tech. Try Hack Me and Hack the Box are usually never used, as although we stream content from both websites, we often swap platforms or stream other platforms in between. So that's an interesting one. So like the fact that this one's kind of up there means that maybe the research tag might kind of be up there as something that people might want. I don't know. The point is, I'm interested to see if we could make research a bigger thing on Twitch, because I honestly do feel like Twitch is a great place to do that type of stuff. Oh man, this is going to be a very interesting stream with that music going on in the background. I'm going to go as long as I can. I can't guarantee I'm going to be able to go for more than an hour, but we'll see how it goes. Anyway, I just wanted to mention that. I'm going to mention it not only on this stream, but also in a few streams in the future, just kind of seeing if we can get more people to vote on it and see if more people are interested in it. I don't know. It'd be great if we could get more people involved. Okay, so what are we working on today? Let me go ahead and go over here and let me open up... Well, let's talk about what we're actually doing. So, I don't know where to start here. So, I've made a post on Twitter and also a post on the YouTube community tab not too long ago, like yesterday evening or something like that, asking what type of content people want to see. More frequent uploads or more impactful uploads, I think is what I said. So, when you think about frequent uploads, you can think of like Linus Tech Tips or something, like not quite daily, but pretty much daily uploads, talking about like how running a business is like, what it's like to be a researcher every day. And not quite vlog style, definitely with some sort of technical project on every video, but not exactly like, 3 blue, 1 brown quality either. On the other side of things, we could talk about, incredibly impactful uploads. And this would be kind of Mark Rober style, where you still get a video out every month, but that video is something relatively new, something people haven't seen before. And it's relatively easy to do that with engineering videos, where people just, I don't know how to put it, but, people are making something new. It's something new with every video. So I was asking which one people preferred. And most people were saying they wanted more impactful videos. Now, a lot of people thought when I said impactful, I meant longer. I'm not intending to make videos of longer duration. I think 5 to 10 minutes is the optimal length for a video. In fact, I think if you could shorten everything to a minute, you should. But that's my own philosophy there. That's probably why I don't do super well on YouTube. But my point was, I asked people what they wanted, and they basically said more impactful videos. Well, they seem to indicate that more impactful videos are the way that we should go, which means I'm going to try to do a thing where every single video I put out from now on will somehow push the boundary of human knowledge forward in a way that maybe hasn't been done before. Hopefully, no, in fact, has not been done before. Now, is this going to be like a super big advancement every time? No, sometimes it's going to be really silly, but the point is I want every video to be something new. And on that note, the stream title and the stuff that I'm working on this week is the world's fastest fractal generator. Now, is that an incredibly interesting thing that people are definitely going to click on? I have absolutely no idea. But it is something that pushes the boundary of human knowledge forward a little bit with, and I'm quite interested about. I don't know if that was a sentence. I'm quite interested about with... You guys know what I'm trying to say. I'm interested in it, and I think it's quite useful and interesting for other people as well. So what does this encompass? Well, it has a bunch of different little things in it. The first of which is something that we worked on before, which was a way in which people can input fractals, a way in which they can talk about fractals, provide them to our fastest fractal generator, right? So that was all of the symbolic logic stuff that we did, I think, Saturday and also last Friday. Today, I want to switch topics a little bit and talk about something different, which will be the fractal flame algorithm. So for those of you guys who don't know the fractal flame algorithm, let's go here. It's something that we worked on like 2 years ago, then we stopped, then last year, and then we stopped. It's something we keep going back and forth with, so it's something that definitely belongs in the algorithm archive. But basically, it creates these kind of really pretty looking fractally patterns. There's a bunch of different steps to it. And we have most of those steps available in our GitHub directory for Flamify. And today what I want to do is just kind of look at the Flamify package, which stands for Fractal Flamify, see where it's at, and see kind of what needs to happen to go from where it's at right now to where we need it to be, kind of this type of stuff. So that's what we're looking at today. Again, there is probably going to be a live concert going on outside of my window in like, if not now, because I can definitely hear people playing music outside. soon. So I don't know how the stream is going to go because it might be very difficult for me to, whenever there's music playing anywhere, I get really flustered and frustrated simply because I really don't know why, but it's something that I haven't ever really been able to deal with. I don't very much appreciate music as a genre, as a thing, and so it's something that I can't really deal with very well. So as the music is playing outside, I may get rather frustrated throughout the stream, and I may have to close it prematurely. That might happen. Again, I'm doing my best to stream every day, but look, there are circumstances outside of my control here, and I'm going to do the best I can, but we'll see how it goes. Okay, so let's go to the Flamify package. Or maybe before doing any of that, let's do an algorithm archive PR to make sure we get something done today, and then we can move from there. So let's do the algorithm archive PR first, just to make sure we're not going to miss anything. So algorithm archivist's here. Let's go to the algorithm archive pull requests and go from there. Fractal Flames plus music visualizer. I'm not intending to do any type of music visualization, although that might be interesting. So these are both like things added to the dev container. I believe it's fine. Let me just take a look at the files changed here. And I'm just going to tag Nick in these really quick. Let's go conversation. And let me just say, well, I think these both look kind of fine. Because I remember looking at them before, but I'm just going to tag Nick and say, hey, if these are good, just okay them, and I'll go ahead and merge them. So let's just go ahead and assign Nick to these, and Tyndall, I believe. Oh, Nick. What is it? Okay. Never mind. Let's, why is it Hacktoberfest accepted? Maybe I need to ask about what the difference is between Hacktoberfest and Hacktoberfest accepted, but anyway, we'll leave these for Nick, see what he has to say. I know that was mentioned on GitHub, or mentioned on Discord earlier, so I know that people are familiar with it. Okay, let's do the 1D convolution in Python, and also maybe we move down. We have the C#. Maybe we do flood fill in C++, see what that one looks like as well. Although Shadow Messiah is up here, so I think they know what the deal is with the PRs and everything. Okay, files changed. It looks like all the Python files are updated here. I'm going to basically run this code, make sure all the results are the same as the Julia code. It looks clean to me. I'm relatively happy with it. So I think I'm happy to merge this guy in. But let's just go ahead and Control H. Shift H. You guys don't even know what that means. So I'm using Qt browser. So Shift H brings you back. Shift L brings you forward. This type of thing. Okay, view command line instructions. Grab this guy. Oh my gosh, this is going to be a really hard stream. Can you guys hear that? No, you guys can't. Just a little bit in the background. Wait, I'm being very quiet here to see if you guys can hear it. Oh, you definitely can't hear it. Okay, well, we'll just see how this goes. Anyway, we'll see how this goes. I think Oktoberfest accepted validates the PR without it being merged. Oh, I see. Fair enough. I think that's good. Oh, no. This is going to be a really difficult stream for me, guys. I'm so sorry. I'm going to try to push through it, but we're going to see how this goes. Have you tried noise-canceling headphones? Yeah, so the problem with noise-canceling headphones is that... Okay, so to be fair, the music outside doesn't bother me so much. The reason it was so bad in my Boston apartment was because both my upstairs neighbor and my downstairs neighbor were playing music that was incredibly loud. It was so loud that even wearing noise-canceling headphones, I could still definitely hear the music. I had the highest rated earbuds in, or like earplugs in that I could find. I could still hear the music. My apartment was literally shaking from the bass, and so I had a very strong like PTSD type of thing anytime anybody played like any type of bass-heavy music around me. Because this music isn't particularly bass-heavy, I'm actually kind of fine with it. I don't mind it too much. But like the moment you start hearing like boom, 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 this type of thing, I get triggered like really badly because I just start to feel like really sick to my stomach and feel like I'm just about to throw up because it was just, the fact was that apartment was like, roach infested, and we found out later it was rat infested, and it was just awful. At least here in this apartment, I have very rarely, if ever, heard my upstairs neighbor, and it was only when they're like moving chairs around and being like very, moving around a lot. That's the only time I've heard them, which is quite nice. The only noise that comes into this apartment is from outside the apartment, and that means that for me, it's okay. I don't mind it so much. I've had similar problems, and it's really annoying. Get triggered myself. Yeah, treble. What? Okay, certain music doesn't bother me, right? Like anything that doesn't have a very strong bass, totally fine with. I really don't mind at all. I'm a bit annoyed sometimes by like the human voice and stuff, but the moment you put that bass in there, man, I don't like it. I really don't like it. But that's just me personally, right? Like, what am I? I'm an old man. What am I gonna say? CD Projekt's Algorithm Archive. 1 second. Let me go ahead and pull down the latest changes and go from there. Oh, this is going to be an interesting stream. Like, I know it's only going to get louder because the event doesn't start until 5:30, and it's currently 4:30. And so, yeah, it's going to be an hour, and then the event starts. It's going to get even louder. I don't know. The top of the terminal is cut off. How's the top of the terminal cut off? I don't understand how that could happen, but let me check really quick. Maybe I have accidentally... How about now? Is it better? Did I fix it? 1 second. Clearly I didn't. I think this is the best I can do. Let me try to resize it. Okay. It doesn't seem too cut off. I think this is about the best I can do. Sorry about that. All right. Let me CD into contents, convolutions. Now let's see here, CD1D and then code. And first I'm going to run the Python code just to make sure it works. So we're going to do Python 1D convolution.py. Ls here, we should have a bunch of data files, and I'm just going to look at the data files to make sure they're fine. I scroll down a bit on Twitch. I hate the guy downstairs. He's always chattering loudly like he's addressing a crowd or something. Your upstairs neighbor. To be fair, I got it. Like, that's one of my biggest fears. Like, this is the reason why I don't like hearing my neighbors. Not so much because I can hear them. It's not so much them keeping me up at night that's a pain, although that was definitely a pain with my last apartment. If I can hear my neighbors speaking, it means they can hear me speaking, and that is a huge fear of mine. Like, you probably don't realize it because, this microphone is right next to my face and everything, but you might be able to tell based on the tone at which I'm speaking. I'm actually not particularly loud. I'm not a very loud person. In fact, I'm fairly certain that my voice is quiet enough that the music coming from the windows right now is louder than my natural speech. Like, if I were to talk next to a window, I don't think my wife could hear me. I don't like speaking loudly, and so I feel like, even if I'm not, I feel like my neighbors can't hear me, and I think that's really a blessing here. But man, it's a huge fear of mine. It's why when I was living with my parents, I actually couldn't stream. Because every single time I tried to, there would always be someone else that they invited over. Yeah, sure, it was during COVID times, but there would always be someone there. And I just couldn't. I couldn't deal with the fact, or I couldn't deal with the mental anguish of people hearing me while I streamed, even though, yes, I am streaming it to what looks like over 20 people right now, and that's totally fine. There's something about someone hearing you from the other room that really just freaks me out, and I don't know what it is. Okay, so I'm going to go ahead and do GNU plot, and we're just going to do plot cyclic.dat. 1 second. Need quotes around that. This should be, yep, perfect. Okay, so there's 2 other data files, and it should be full linear. There, perfect. And the last one should be simple linear, and it should provide... Oh, is that right? I don't think that's right. Let me double check. 1 second. So we're going to go to convolutions in 1D. Maybe I'm just an idiot and I forgot what it's supposed to output. Okay. We're just going to scroll all the way down to the bottom here. Sorry, I have the hiccups. Oh, that is correct. Oh, right. It's correct because it's only grabbing up to here of the full linear output. Perfect. Okay. In that case, it's producing the right output. Let me double check the code to make sure it looks clean, although it did look pretty clean to me. And then the last thing I need to do is just double check to make sure all the line numbers are correct. Okay, from SciPy, import FFT. Do we need an FFT for this one? I don't think we do. 1 second, let me look for FFT. I believe it's only used there. Yeah, so here I'm just going to say, I don't believe we need the FFT library for this one. Oh no, don't be that relatable. It's scary how accurate that feeling describes mine. Yeah, I mean, yeah. Anyway, so I don't believe the FFT library is necessary for this file. Add a single. Well, we're going to start the review. I would take a quick look at the start and end of the .dat file to make sure there's no off by one errors. That's a fair point. Let's go ahead and do that as well. Convolve cyclic, convolve linear. The functions look fine. I mean, they look good. The functions look fine. Let's see. X, Y, float, simple. Okay. So let's double check the file. So we're going to, what am I going to do? I'm going to cd back into the Julia directory, and we're going to run Julia 1dconvolution.jl. I think there's like a main function that I'm not running down here, and I believe this is just main. Yeah. So let's just go here, main. All right. Julia 1dconvolution.jl, ls here, and now let's just go ahead and look at cat. I think, what is it, T10 cyclic.dat, cat 10 head is what I'm looking for. Cyclic.dat, and then head of Python cyclic.dat. Okay, so this is going to be hard to validate, isn't it? Why are they off by a bit? They have 0.5, 0.4. So one is 0.5, the other is 4. 4. The other is 4. Let me do tail. Okay. Let me do full linear instead. So we're going to do head of full linear.dat. And now let's do, and now let's do head of, what am I doing? Python full linear. Okay, I mean, 3.05, 1. Why are we off? We should be exact, shouldn't we? Or at least like very close to exact between the two different languages. I'm just going to mention that, like, here's what I'm going to do. I'm going to show just the head here and be like, hey, there seems to be an issue. Yeah, I'm just going to show this and be like, okay, so I'm just going to say the shape of these, the output, one second, looks correct. But, did they not normalize? Maybe that's the issue. Did they not normalize it? Maybe that is the problem. Oh no, it's normed here. Wait a minute. Maybe there's something weird about the normalization. Maybe? Anyway, the numbers. I am not sure if this is a problem with the Julia or Python implementation. Okay, so let's just go ahead and paste this here. And I'm just gonna kind of paste the lines. Okay, I'm not gonna paste the lines. In fact, I don't know what I just did. So let's Control Z twice. And let me try this one more time. So I'm just gonna go here, open that up, grab these lines, cyclic.dat, cyclic.dat, go over here, paste that there, and now submit review. Okay. The shape of the output looks correct, but the numbers seem a bit off. I'm not sure if this is a problem with Julia or Python implementation, and then I also mentioned this. I would take a quick look. I just brought this up because I had some struggle getting my C# implementation working correctly due to Julia starting off indices at 1, and it's a different MD mod function. Okay, that's actually really good to mention here. So in the, apparently in the C# implementation, where is that one? C#, Windy convolution in Julia. maybe I just do 1D. Oh, I don't remember. There was some problem getting the implementation because Julia starts counting at 1. Let's see. Julia starts counting at 1, and thank you. 846. Number 846. Where are we? There we are. Perfect. There's some problem getting the implementation working because Julia starts counting at 1 and uses a different mod function. Okay, let's go ahead and just make that comment there. Thanks for that. Otherwise, I wouldn't have really thought of that. That's good. Thank you so much. But the shape looks good. So, I mean, obviously, it's just like little implementation details that need to be changed there. Let's take a look at pull requests, see if there's anything else we can just very quickly merge in or discuss. There is approximate counting in C. I want to see where this one's going. Let's see. This might be nice to add. Oh, right. I said otherwise I think it's fine to merge, but then they didn't say anything. So now I'm not really sure. Maybe we just go ahead and merge it in even though it doesn't have compilation instructions because, you know, we kind of know what the compilation instructions are. It's GCC approximate counting. And we're going to kind of fix that hopefully with the standardized output and stuff. Okay, I think we can skip the instructions as Cons will do that for us later on. Yeah, I think you're right. I think I'm just going to go ahead and mention that here. So I think because let's see, because we're moving to a scones infrastructure, don't compilation instructions. And 1 second. All right, I'm just going to put this as an approving review. Let's go up here. Where are we? We need files changed, review changes, paste that there, approve, submit review. And I believe everything's good to squash and merge. All right. Nice. Perfect. Great. Okay, let me get a quick sip of water and then we'll move on to the Fractal Flame stuff. Also, they don't seem to be playing music now, so I'm gonna play just a little bit of music in the background until they start playing music again outside. Whew, it's gonna be a tough stream, guys. Like, way tougher than I thought it was gonna be. Let me move over here, open up Xernal PP. Right, so I don't know where to start this discussion, actually, if I'm being totally and completely honest. Let me get a little bit of water. Okay. One more thing I do want to mention, just because I mentioned it before, and I don't know how much longer we're going to be able to stream today. If you haven't already, and you're interested in seeing more like research streams and stuff like that on Twitch, feel free to fill this out. It's just a very quick, like, just, you know, very quick click of a button, you know, about potentially having a research tag on Twitch. The idea with the research tag would be that anyone who's doing academic research or potentially, you know, citizen science, pushing the boundary of human knowledge forward just a little bit, you know, could stream under that tag, and that'd be really helpful for people like me, people like you, who are looking for other people who are doing research on Twitch. That's the whole thing, you know, like we have a whole bunch of other tags that I feel like would be less used. And I really do want to see like more like research done on Twitch. I think it's something that would be really good for Twitch. And I think a lot of people would be really interested in seeing on Twitch. I said Twitch like 10 times in the past, you know, 2 minutes. But the point is, you know, I really just want to see more research, and I don't see it on YouTube. I don't see it anywhere else, you know, on the internet. And so I figure if you're going to make it a thing, you know, you should be the one to start it, and you should just make it happen, you know, even if it ends up being that someone else, you know, becomes a much better researcher, like their, you know, gumption, their forward momentum is much stronger than mine, at least trying and starting somewhere is important. Hey Arsev, how are you? Let me go over here. Okay, I'm checking some notifications, and then we're going to go ahead and get started with, with stuff here. So, 1 second. Okay. Sorry, I have to take a look at some notifications on the side here just to make sure I'm not missing anything. I don't think I am. Good to go. Okay, so today we're going to be focusing on the fractal flame method. So fractal flame method. So again, we method. Come on. There we go. For those of you guys who don't know the fractal flame method, it might help to start with something a bit more basic, which would be the iterated function system. Yeah, actually, I don't know how long it's been since the last time you've been on stream. The truth is, I've been super, I don't know how to put it. I've just been really not consistent with streaming, is what I should say. I have not been consistently streaming for the past N years, where N is probably 3. And the truth is, I'm going to be more consistent, at least this month. For the next 3 weeks, I've promised myself I will be streaming every day. Sure, I might get a little bit burnt out at the start. I might modulate the stream time so it's not super long, but I want to slowly but surely get back into it. And I really want to start making sure that, I get content out, not only on Twitch, but also on YouTube, also in the algorithm archive. It's why I spend, 30 minutes to an hour a day doing the algorithm archive work. I really do think it's important to start pushing this type of stuff. Okay. So let's start with the iterated function system and build that into the fractal flame. The easiest way to think of an iterated function system is to imagine a function system, like this one right here. Wow, what an amazing function system. Need to get some stuff done. See ya, Silent Tree. Thank you so much for coming in. Hopefully we'll see you around tomorrow. And hopefully I'll be streaming for a bit longer tomorrow, like maybe from 1 to 8 p.m. I don't know. I'm really trying to get down I want to do like an 8-hour stream a day. I want to make it so I put my full workday on Twitch, but I haven't quite gotten to that level yet. Datemar CH, thank you so much for following. Really appreciate it. Okay, so what is an iterated function system? Good question. Imagine you have a function system, function 1, function 2, and function 3, where one is PA plus 2, P plus A over 2, the other is P plus B over 2, and the other is P plus C over 2. What these functions essentially do is bring you halfway towards A, B, or C, because it's the average of the 3. So, I'm not doing a very good job of this at all. Let me try that again. Okay, here's what we got. Each of these functions bring you halfway towards A, B, or C. So function 1 brings you halfway towards A, function 2 brings you halfway towards B, and function 3 brings you halfway towards C. I'm struggling today, guys. I'm really struggling. So imagine you create 3 new points, D, E, and F, and you have each of these create 3 children that follow the functions as we described before. Well, in that case, you'd have 3 down here, 3 up here, and 3 down here. If those kids then generated more kids and more kids, you start to see some go, all over the place. And eventually you start to recreate the structure that is the Sierpinski triangle, a triangle of triangles, right? This is known as an iterated function system. Hey, Datemar, how are you? Finally can catch you in a reasonable Moscow time. Yeah, so also, as far as streaming is concerned, when I was in Japan, I only really had 2 hours I could stream, and that was from 5 to 7 a.m., which meant that I was sometimes late to stream because it's 5 in the morning. I couldn't leave, I had to leave at 7, because if I didn't leave at 7, I wouldn't make it to work on time. Sure, okay, after stream, I would often go to the gym, but, the fact is, that's a necessary part of my life, going to work out, stuff like that. So I only really had that time. And then when I moved to MIT, I could not find any time whatsoever I could stream. The first 3 or 4 months I was in Boston, and I just couldn't stream because my upstairs and downstairs neighbors were being too loud. I was self-conscious, as I said before. I just couldn't do it. I then went to live with my parents, and again, I tried, but I failed. I could not stream there either. And then I went back up to Boston, and again, I couldn't stream there because I was so busy with the MIT work. Then after that, I ended up going to Okinawa, and in Okinawa I was able to kind of do a few streams, but I was in the middle of my 5th move, one of which was international, and then I had one more international move to Barcelona after that, and it was just a pain. It was such a pain, man. But now that time is over, and now I finally have a stable living conditions. For the first time in 3 years, I finally have some sort of forward momentum, and I can just hit the ground running. I've been trying to run for the past, I don't know, forever it feels like I've been trying to just hit the ground running and I haven't been able to. And now I finally have that time and I'm going to take advantage of it is what I'm going to do. Anyway, that is a huge aside there, and I do apologize for that. Let's talk about iterative function systems, shall we? So the idea here is that we have the function system, and we can iterate through that function system in some way. It doesn't really matter how we do it, but as long as we, adequately sample the space, we are able to create the attractor of the system, which is known in this case as the Sierpinski triangle, but in other cases you can generate a different attractor, like for example the Barnsley fern with this set of functions. The fractal flame method essentially extends this concept. So each of these is considered a flame for the overall fractal flame method. So you could, for example, combine the Barnsley fern and the Sierpinski triangle together by creating a superset of the two. So the fractal flame method is simply a way to combine these different function systems together. And it allows for you to create a bunch of really interesting designs and patterns and stuff like that. So what I'm going to do first is I'm going to take a look at the code that we've already written for the fractal flame method and just see what it does. Make sure it does what we expect it to do. Then after that, we're going to take a step further and see what we need to do to develop it and to make it useful for what we want it to be useful for, which is the world's fastest fractal simulator, right? So where does this fit in that? Well, the actual underlying algorithm that is the fractal flame algorithm is simply the iterated function system, right? So what we're looking for is a way to just kind of plug and play different iterative function system methods. So, we want to be able to test other people's iterative function system method. And then we want to be able to test our method, right? So we need to kind of just be able to plug and play a bunch of different things. So basically what we want people to be able to do is, one, write down equations, two, have those equations be solved with our iterative function system generator, and three, for it all to come together into a like one cohesive package, and that cohesive package will be the fractal flame method. What do you use for visualizing? So right now what we do, and I'm not saying this is what we're going to do definitely, but this is what has been requested and what is expected of users to do for the fractal flame method, is you generate like 10 million points, right? And then what you do is you bin those points into pixels. So if there are like 5 pixels available, or if there are 5 points available in one box, and that box is a pixel, then that box is particularly dark. If there are, no dots available in another box, then it's essentially white, right? And that's what we did with like these images here. So let me just do, I actually don't know how to open this up. Copy image. All right, I'll just go right over here. Control V. Okay, so that's what we did with this image here, where essentially okay, 1 second, I really am trying. There we go, that'll work. Okay, this is what we did with this method here. So it's really just one giant image where each dot is plotted and colors in the pixel for that dot. So that's kind of what we're going to be doing. I'll explain it in more detail as we go further, but that's where we're at here. It's not sophisticated. I could do something like OpenGL or something like that. Did the Mandelbrot once with Manum like that? Yeah, you can definitely do, like we've done that as well, like the Julia fractal and stuff. The difference is that these types of fractals are generated in fundamentally different ways, right? So usually for those types of fractals, and I'm not saying this is how you always do it, this is just how I know how to do it. For those fractals, you typically will have some sort of like complex field that you're plotting or something like that. In which case, backends like Cairo, which I think Manum is now using that backend, but backends like Cairo require you to have like each pixel colored in a certain way. This one is generated slightly differently. It's using the iterative function system method instead of like a complex domain type of method. So yeah, that's the only difference here. Other than that, it's kind of the same. All right. Let's go ahead and CD into projects, Flamify here, CD into projects, Flamify, and let's just open up an image. So CD projects, Flamify. All right, move this down here under my face. Perfect. Here, and now I'm just going to open up an image. So Mirage, probably save.png, save one.png, perfect. All right, so here's some of the fractal flames that we've already generated. I don't really remember what we're combining here. I know we're combining 2 different fractals. One is a heart fractal, I can see. I'm not sure what else we're combining, but this is just a combination of a bunch of different, fractals put together. Note that when we did the fractal flame last time, We actually, sidetracked ourselves and talked a lot about convolutions and stuff. We went very far into different avenues with the fractal flame method before. The hope is that we have all the necessary tools now to finish up the chapter on the fractal flame algorithm for the algorithm archive. But like I said before, I don't necessarily want to make a video on the fractal flame method. I think I want to leave that entirely in the algorithm archive, and instead focus on the world's fastest fractal generator for my next video. This means that I'm not wasting time like just doing video editing and stuff like this unnecessarily. I can spend that time focusing on, actually producing cool stuff that people haven't seen before. And that's really what I want to focus on. So I'm going to leave this image in the upper left-hand corner so we have some sort of visual flair. Ooh, well, that's maybe something like that. It's fine. All right, perfect. So I'm going to have that up there so, we can kind of flip between the images as we need. I don't know which one's actually coolest here, but it'll be up there so people can see it as they come in and they kind of see what we're looking at. Okay. Now I need to look at the code because it's been months, man. It's been a long time since I looked at the code here. I really genuinely don't remember what any of this is. Also, what is 296.pdf? All right, so you and me, we're gonna, pick apart this code and see what we're gonna pick apart this code and see what needs to be done. So first of all, let me take a look at what 296 is because I don't know what it is. Algorithms for fast fractal compression. Oh, this is when we got into fractal compression. Oh, yeah, we'll talk about that later. Okay. A few days ago, we had the discussion about how legal it is for me to open up papers on stream, and we kind of settled on the belief that it's not particularly legal for me to do it, but no one's going to call me out on it. And I've just kind of realized that, screw it, I'm just going to do it. If something is obviously behind like a paywall, and if I have to find it, if I can only find it via Sci-Hub, that's one thing. But if it's freely available online and I can find it and I can browse it without having to be under a VPN, I kind of feel like maybe it's fair game for stream. It's not fair game for YouTube videos. It's not fair game for many other things. But I mean, what am I supposed to do? I mean, the act of researching requires you to read other people's papers, to go through other people's research. And if I'm not able to do that on stream, I mean, I'm fundamentally limited here on what I can do. I don't know why I did that. I just put a train on my screen for no apparent reason. Okay, let's just go ahead. I was trying to clear my screen, and it didn't even work for that purpose. So let's keep going. Okay, I'm going to go over here, run Julia -- project. And let me just see what we have here. So I'm going to cd into notes, ls. What is all this? What was I doing? A review on fractal image compression. Man, I was really deep into fractal image compression back when I finished this up. Okay, so over here we're going to be using Flamify, make sure it still works. It does not. Okay, instantiate. All right, instantiate. All right, let me just rebuild everything, make sure it works. And now we're going to try using Flamify after that's done. I might need to do using revise as well, but we'll get there one step at a time. Again, there was a discussion I had the other day, I might as well bring it up now, where I wasn't really sure what category I should be streaming under whether it should be software and, game development or whether it should be science and tech. I don't know, I'm 50-50. For now, I'm streaming under science and tech. I might change that to software and game development later, but I mean, the fact is, like, if you like the stream, if it's something that you would recommend to a friend, for the next 3 weeks, I'm going to be doing this pretty much full time. As in, I will be streaming for over 40 hours a week, every week. I'm hoping, that's what I'm really hoping for. And if this is something you want to see continue, then let me know. So, I'm really trying to make this a thing. And the next 3 weeks, I've taken off of absolutely everything else and focusing exclusively, all I'm focusing on is Leos Labs. So I'm going to make sure I can get a video out by the end of the month. I'm going to make sure that I stream as regularly as I can, get some chapters out on the algorithm archive. I've got so many things I'm going to be working on. And if this is something that you like, then, let me know and maybe share it with a friend. I know that sounds really lame to say, but I mean, I'm really trying to make open research a thing, and I don't really know how to do that. So I guess I need your guys' help with that. You know what I could probably do? Let me try something. I'm gonna make this bigger. by going, okay, that's not what I meant to do. Okay, let's try this again. 1 second. I just deleted my terminal on accident. And I know what you're saying. Use tmux. Yeah, I'm sorry. Okay, so we're going to cd into projects, algorithm mark. We're going to cd into projects, flamify. Hell is here. Yeah, Julia, double dash project. Now we're going to do using flamify. I don't know what the research command is supposed to do, but if it's supposed to tell you what I do for research, let me go ahead and do that really quick. I'm just going to make this bigger, slightly bigger. Perfect. Okay. Let me go to github.com and let me do algorithm archivists. Now we're going to do algorithm archivists, projects, Laos Labs. So here's kind of a list of the interesting projects I'm working on right now. Sorry, the first column is the world's fastest fractal generator. Then what I'm doing next is hopefully going to be a 4D galaxy simulator. I'm hopefully going to be collaborating with with 3 Blue and Brown on that one. Then enhanced fractal compression for HD video. This simply means I want to create a video where every single frame has been fractal compressed, so every single frame is a fractal of some sorts. And then the big one, physics simulations without data. I don't know if we can actually do this one, but if you can, it's huge for science. It's probably going to make a really crappy video. I don't know how to make it an interesting video because it's not super clicky, but like it's going to be really cool if we could do that. It's so nebulous right now. I don't really want to go into it. But then we have some knot theory stuff and different stuff there. If you're a researcher yourself and you're interested in maybe having someone help out with some sort of computational science thing, like, you know, you might need GPU support or something like that, let me know because I could potentially be into that. It really just depends on what I can fit into my schedule and what I feel is the most interesting to talk about, blah, blah, blah. But that's kind of where I'm at right now. I really do strongly feel that there's a way to make this work. I just don't know how to do that. Wait 1 second. I'm getting a call. Give me 1 second. Hello? Hello, wait 1 second. Sorry about that. Okay, sorry about that. I needed to fix something on my end. All right, so I think we're back to it. Basically, we just moved in, and there's a bunch of things that need to be fixed with the apartment. One of them happens to be the washing machine and dishwasher. Washing machine and oven, I think, need to be fixed. So someone just called saying they're going to come on Wednesday to fix it. That was it. I promise I'm not pulling wool over your eyes. Okay. Let me see. I think everything else is fine. I'm actually excited to see how is your idea of open research would come. Yeah, I'm actually. I genuinely feel that there is no reason for researchers to keep their research like behind the closed doors of academia. I genuinely feel that having an open research lab where anyone can collaborate, anyone can help. I think I don't see a problem with it. I think it's going to be amazing. That's why I really believe that like having a research tag on Twitch would be super helpful. And I keep refreshing this page, hoping for a few more votes, and we got a few more votes. But I really am genuinely hoping that researchers are just more open about their research because, yeah, look, there's a lot of problems in the world today, like a lot of problems. And the way I see it is there's so many issues that need to be tackled. It's impossible to do all of them. So you as a human should just focus on the one that you feel is the most important to you and tackle that problem. And to me, that's open research. And the reason it's open research is because, well, I feel like We've got a lot of problems with climate change. We have a lot of problems with, science policy. We have all these problems that are really fundamentally screwing younger generations. And if people just believed researchers more, if people understood the process of research a little bit more, that would genuinely go a super long way in people better understanding what it means when 97% of climate scientists believe in this thing, what it means when someone says, researcher has recently shown that, chocolate makes your baby fat. What does this actually mean? What do these studies actually show? And I think having an open research lab really tackles that in a way that a lot of other people are not considering, right? Sure, okay, the climate is a huge issue. But the reason it's a huge issue is because people don't believe climate science, right? And so to me, the fundamental problem that needs to be solved is communicating research to the general public. Obviously, climate change is the fire we need to put out now, but anti-intellectualism is the bigger, broader, systemic issue that we need to tackle. Anyway, that's my own personal opinion, and that's why I think open research is important. Okay, let's get off the soapbox and start talking about actual stuff to do. Clive 10101, hey, how are you? I hope you're having a great day. Okay, I'm going to take a look at this code and see what we actually have written up. I genuinely don't remember anything. So, we have flamify.jl. Let's open that up first. This takes into, no. Okay. So we have transformations.jl, flames.jl, fractalflame.jl, and imagetools.jl. Let me just see how this is written and think about how we need to improve it to go from here. I guess we're just going to open up one file at a time. So first, what is flame structs? Flame structs. I'm pretty sure it's just a point and a pixel. That's it. Right, I mentioned this before, but the way the fractal flame algorithm works is you generate 1 million points and you transfer those points into pixels. Look, is this the best way to do it? Maybe, maybe not. I don't really know. But this is just how it's done, and this is how it makes sense to write the fractal flame algorithm. Okay, so the next one we want to look up is, what's the next one? Transformations.jl, vi transformations.jl. Okay, so this is where... Oh man, a few months ago, we actually looked into affine transformations because I fundamentally did not understand this. This is what I didn't understand. How and why do you multiply? What is an affine transformation? And I knew it was like a linear transformation with a with some sort of shift or movement. But I didn't know why, I didn't know how it worked. And then everyone was saying to use this augmented matrix approach, but no one gave me a good explanation of how it worked. And then we ended up, creating the affine transformation chapter of the algorithm archive. I spent super long time, months on this, right? Literally months on this. And for those of you guys who were thinking, wondering how long I've spent on the world's fastest fractal generator, well, let me just tell you, I spent over a month on this one chapter alone, which I think is quite good. But this chapter and video that goes with that, we talked about iterated function systems, the Barnsley-Fern system. We talked about different ways in which you can generate fractals via counting, which is why we also talked about the approximate counting algorithm, which should be down here. I know it doesn't seem like it, but we've actually combined 10 5 different algorithms in the algorithm archive that we've put together into this video. In fact, we even talked about flood fill because I initially thought it could be useful for the fractal flame method. All of this is all related to this one thing that we're doing right now. And so I don't know, it's when you talk about research, the reason it's such an interesting thing to me is that it's a combination of a bunch of smaller things all put together into one big thing, and it's super cool because you start to see all these little pieces of the puzzle come together. Okay, do I actually understand why we have affine rand here and affine here? No, I don't. I don't understand at all. We have A, and then we have P, which is a point, and we have the point's X and Y location, and we return... Oh, I see. A is the affine matrix. Gotcha. Okay. Next up. Oh, by the way, guys, if I say anything that's kind of weird and you have questions about it, please feel free to mention it in chat. That's one reason I'm live streaming this. If there is anything I say that you don't understand or you think I said incorrectly or anything like that, just mention it in chat. There's that level of interactivity that I think goes a very long way. So I speak quickly with the assumption that people will stop me and ask questions along the way. Okay, let's go into flames.jl. I believe this is just a conglomeration of different fractal flames that I've put in, although not yet complete. I think that's true. Okay, the next one I want to look at is probably image tools.jl. Okay, so this is where a lot of work. Yep, okay. We're going to run the code in just a second, but I see a lot of to-dos already. Figure out how to select the best deviation factor. Do I remember what a deviation factor is? No, I do not. To-do. All right, there's one to-do. Here's the next one. Maybe normalize channels altogether, not separated. Okay, don't know what I'm talking about there. The normalization of colors seems off, creating a spotty output. Great. This is computationally complex. Kind of sucks for that reason. Too many pixel sum functions. There's like a to-do on every function here. What on earth? Like, where did I leave this package? So how many pixel sum? Oh, so we have pixel sum 1 here, which takes a signal and a filter. Okay. And then we have pixel sum here, and then we have fractal convolution. To-do, we need to figure out how to make a variable sized filter. We need to read in the point data to figure out filter size. I believe this is actually a correlation, not a convolution. Dang it. Okay. Does that mean I'm actually not going to be covering correlations if we need to. To-dos in here as well to log scale, check to see if this is an approximation to log implementations. We need to write the image. Okay. And finally, the fractal flame method. Let's take a look there. So here's the thing. When you open a file, and the first thing you see is 4 to-dos, one of which has 2 sections, so 6 to-dos. Yeah. I don't know what to think about that. Let me see what other to-dos I have to do. All right. Okay, good. They're all at the top. Let me see, how long is this file? Set number G. It's 74 lines, so it's not super long. All right. Set no number. Okay, so let's collect all the to-dos, try to figure out what actually needs to happen here, and then just start hacking away. Even if at the end of the day, because again, there's a concert outside, all this kind of stuff. So even if at the end of the day's stream today, we end up like just kind of listing out everything that we need to do, I still will consider today to be a success. The point is just to figure out what we need to do, right? And figure out where this fits into the overall puzzle, all this kind of stuff, right? Because obviously there are some bigger to-dos to do here. Like we need to add in kernel abstractions. We need to find a way to plug and play different iterative function system methods. It's just a lot of little things that need to be done. So we'll just tackle it one step at a time. And again, guys, if you guys have any comment, questions, concerns, anything like that, just let me know, and I'll totally address it as soon as I see it in chat. Okay, so super sampling must be implemented by increasing the number of bins before sampling down. Gamma correction at that stage. Density estimation with dynamic kernel related to the number of points in the bins. Lower points is broader kernel. Okay, more blurring. Okay, I see what's happening here. Okay, I'm going to explain everything in just a second. Let me read the to-do statements, and then I'll kind of explain what each one means. So parallelize with large number of initial points. Yep, that's to do with kernel abstractions. We'll get to there later. So next, we need to allow affine transformations to have a time variable and allow for super sampling across time with different time steps, all falling into the same bin. Might require 2 buffers, one for log of each step, another for all logs. Don't know what I was talking about there. And then we need to think about directional motion blur. Okay, I don't know where to get started here. I'm going to actually open up a few new terminals just because I feel like that's where I do need to get started here. Anytime I'm confused, I always just open up more terminals. But let's go here, there. Take this, make this on all desktops. Move it over here. Okay, perfect. So I'm going to cd into projects, flamify, ls here, and let's just go into vi flame draves.pdf. Ocular flame draves. Of course, I want to open it up in Vim, right? What was I thinking? Okay. So, there are a lot of bits and pieces to the fractal flame algorithm. And the question is, where do we start? Where do we go? What are we supposed to do with this thing? I don't know. I really genuinely don't know. I don't know how far we need to go here, right? So what we're doing is we're testing the world's fastest fractal generator, right? the depth to which we need to go for the fractal flame algorithm is unspecified. By that I mean, do we need a full implementation? Probably not, right? Like we don't need everything, do we? I would reckon no. I would reckon we can do a partial implementation, but let me explain, I think, how far we got and what needs to be done to finish up what was written in this paper, right? I'm just going to kind of go through this paper quickly, just because I've been through it so many times at this point. I kind of understand, or at least I should understand all the little bits and pieces. Let me move a little bit. I don't know about you guys, but I don't know if anyone else does. I'm sure other people in the chat do this as well. When you sit in a chair, do you ever just like bring your legs up Indian style? You know, like, is Indian style? You know what I mean? Like cross-legged. Yeah, I sit like that all the time. That's like that's how I prefer to sit. I don't know why. I was just wondering if other people do that or if that's a just me type of thing. Okay. So, all the time? Okay, good. Because I started to realize, like, this is how I prefer to sit when I'm typing and everything. But, I don't know if, surely other people do it, right? Anyway, okay. So, classic iterated function systems. Again, we already introduced iterated function systems. If my legs were flexible enough, I would. Oh, really? Peter, what's up? It's been a long time since I've seen you here. I'm currently in my third semester of CS Masters, and getting pretty frustrated with not getting to program stuff for any bigger works, like theses, etc. Like, how can I cite many papers when I'm trying to find a way to implement something? It looks like you are managing to do this right now. Do you have a few pointers? Yeah, okay, so maybe we do talk about that. If you guys don't mind a slight ramble session. I feel like part of I realize that in some sense, we're always off topic. In another sense, I think it's really important to talk about things like this. So I'm going to take a brief side tangent into this. So there's a little fractal flame method. And let's talk about the difference between papers, broader scale, academic work, and we'll say software engineering. Okay, so here's the thing. If you're an academic, generally speaking, academics don't care too much about software engineering, right? And they don't generally care too much about it because, I'm saying this in a very weird way, but academics don't care about software engineering because, in general, they're only focused on getting papers out. They're only focused on getting like the immediate result done, right? So they're going to write something that might be a little bit crappy from the software engineering perspective, but gets what they need to get done, right? Whereas in industry, you're usually focused on, having a huge software project or that builds into something bigger, right? So you need it to be, rigorously tested. You need it to be, solid fundamentally and stuff like that. So a lot of times if you, software is just a means to the end. Also, Core FTW. I feel like it's been a while since I've seen you here as well. Thanks for coming in. I hope you're having a great day. But exactly what he said. The software is just a means to an end, right? Which is super frustrating as a research software engineer because I feel, from the perspective of a research software engineer, that software is fundamental to most academic work nowadays. And for if you want to have, good reproducible science, then you should have good reproducible software. So, maybe I misread your question, Peter. And if I did, please correct me. But there is this constant struggle, at least within academia, of doing proper software engineering and proper academic work, right? Because to do the academic work, you have to be on top of things in terms of like research papers and making sure that you've read the literature every morning. But in order to be on top of things with software engineering, you got to make sure you have all your unit tests. You have to make sure that integration tests as well. You have to make sure that everything is building a cohesive software whole, which is another project entirely. So there is a constant struggle here. And what I typically do, and I don't know if this is the best way to do it, but I'm typically always reading academic work. Like I'm reading papers all the time. I love reading papers. It's what I do as a hobby. And then when I find something significantly interesting, like for example, the fractal flame method, I take the time to do my best implementation or my best shot at an implementation in my favorite language, in this case, Julia. Now, the interesting thing about this guy is that he actually did produce the software, like the code is available. I think it's like Flam 3. Oh, that's not what I want. Flam 3 Draves should find it. Yeah, I believe this is it. So the code is actually available here. I couldn't quite get the code to work, but it is available here, so you can actually look at it. And so in some sense, I will sometimes look at people's code. But my naive answer to your question of, let me reread it. I'm trying to find a way to implement something. Wait, your direct question was, you're getting pretty frustrated with not getting to program stuff for any bigger works, like theses, etc. How can you cite papers when you're trying to find a way to implement something? Right, like that's just how it is. That's a constant struggle with being a research software engineer. I feel myself right in the middle, like figuring out how the abstract approach and how I can achieve something. But I also want to actually see a working system in the end, and one that goes beyond a demo, how to do one specific aspect. At the same time, I'm not too hyped about building a working system into a 99% reliable thing. Right, so that I 100% feel you. Like that is the core problem of most researchers in the field, right? Like most people do want to see something. Like they want to see a working model. They want to see their code or at least their system creating something, doing something interesting, right? But, does it actually need to be super rigorous? Like how far do you need to go with that? I don't know. And so for me personally, my pointers, if I have any, would be, papers, if you're interested in research, papers are more important than software in some sense. I hate saying that, but it's kind of true. Because papers will generate ideas. You can read an infinite number of papers, but you can only write a few software packages, right? That's what I think I should say. Development time takes a lot longer than literature review, right? So what I would recommend doing, and what I typically do, is I read the literature until I find something significantly interesting. And then I wait a second and I think about it, and I think about other things, and I do a rigorous literature review. I look deeper. I look at the forward citations, the back citations. I look at everything, and then once I have an idea, I'm then like, okay, now that I have the idea, I need to make sure I've implemented each individual part of the puzzle as rigorously as I can, and the question is the same question I just asked. How rigorous do we actually have to implement the fractal flame method? I don't really know, and I'll explain why I don't really know in just a second, but this question is a very difficult one to answer. So my answer is I just do things as rigorously as I feel I need to advance my own research goals. If I feel like I'm wasting development time on something that's unrelated to my research goals, then I get really frustrated with myself, right? And so for me, and the reason I don't consider myself to be a good software engineer is, for me, every time I'm writing code, I'm always asking myself, how does this code push the boundary of human knowledge? How will it build into the bigger picture of the research that I want to do? And the answer is, if the answer is it's not really doing too much, then I really get unmotivated to work on it, right? So I always like to try to figure out how it builds into the whole. Like I have, not on me right now, it's upstairs, but I have a notebook filled with just like, loose leaf papers that constantly like drawing lines between here and there, trying to figure out how this paper relates to that, how I could do this, and what an interesting project is here. Like that's just what I spend all my time doing. I'm not saying that's what you should spend all your time doing. It's just as one data point. That's where I'm at. And unfortunately, I can't go any further with this discussion than that. So I hope that was helpful, even though I know it probably wasn't. It really helps getting mirrored at least. Thank you for the answer. Yeah, I'm sorry. That's the best I can do. But let's keep going. One thing I also, just for the record, when people ask me questions like this, I do tend to answer them a bit more fully than I would answer like if it was just a one-on-one conversation. I want to make that clear. And the reason I do that is because there is a chance that people don't understand the full scope of the question being asked. And so you have to take a second to explain, why the question is being asked to begin with. And so that's why I kind of do rant and ramble a little bit, because I feel it's important to set the stage for the whole question, why it was asked, and all this kind of stuff. So I say that because sometimes when people ask those questions, they'll respond like I'm being very condescending to them. And I just want to be very clear. I'm not trying to be condescending. I'm trying to give everyone else in the room like a clear picture as to what's happening. Anyway, I feel free to give me feedback on whether I'm doing that well or not. Look, Negative feedback always hurts, but in some sense, it's the most valuable form of feedback. Okay, so let's go through this paper and talk about what it is and why I think we might not need to implement the full fractal flame method for this to be effective. So it starts with the iterated function system, which, as I said before, is just a conglomeration of different function systems put together in order to create some sort of fractal. Like, for example, I think he calls it the Sierpinski gasket, but yeah, Sierpinski triangle is what a lot of people call it as well. This will allow us to create a whole bunch of interesting patterns like these up here. Okay, so once you have the ideas of the iterated function system down, he then starts talking about variations. Now, this is where I get super confused with the paper. I've read this part of the paper like 6, 7, 8, 10 times. I have no idea, a huge number of times. 10 isn't that many. I think I've actually read it like way more than that. But I have actually been struggling a lot to figure out what is meant by this section of the paper. And I might actually be reading it through again later, even on stream, to figure out what it is. But essentially, you have a bunch of different function systems that you can use to generate different fractals. And you combine them together to create these interesting, patterns that you see up here. So here's where I don't know exactly what we want to do with the fractal flame method. See, there's a lot of these post transformations that you do essentially to make the fractal look prettier, like final transformations, log density displays. Let's see, what do we have here? Coloring, just to make sure each fractal has its own color. The gamma factor, this is essentially a way to like lighten up the image at the end. And then filtering, which I think we actually did as well. I think we've done filtering, but I think what we didn't do is motion blur. And that is to say, if you have a moving target, something that moves with time, how do you identify what parts are moving, which parts aren't? So we're gonna have to go through the motion blur and the directional motion blur a bit. And I'm wondering what you guys think. Is it important to actually have the motion blur? I mean, look, we are generating fractal flames. Like clearly, where is it? Clearly, it's right here. Like we're generating these guys. They exist, right? So, oh no. Something like that, maybe? I mean, we have it working. It's just, maybe it's not as pretty as it could be. I have no negative feedback to give. I found it helpful and was not irritated by the extent of the explanation. I'm watching for a bit, but I have to jet now. Be safe. Hopefully I can get back in a bit. Yeah, see you, Nick. Hopefully I'll still be streaming when you get back in. It might be a short stream. It just depends on what's happening outside of my window. They're supposedly starting in like 15 minutes at 5:30. So if it gets really loud and I'm unable to stream further, like that, it is what it is. I'm going to do the best I can. Also, my time zone, 5:30 is in 15 minutes. I just have to be clear about that. Let me see. I'm just checking notifications here. Again, just want to make sure I didn't miss anything. Perfect. Let me get some water. And let's just see what the Fractal Flame, fflamify.jl, what it currently does. And then I'm going to create some more to-dos of what needs to happen at that stage. ALE Brave, thank you so much for following. Really appreciate it. Okay, so let's go. The next thing I'm going to do is just run the code. That's it. I'm just going to run the code. I don't know if I have any tests or not. I should. If I was a good Julia developer, I would, but I'm not a good Julia developer. Let's see what we have. L is here, CD backup directory. L is here. I don't have any tests. CD source, L is here. How do we use this package? vi fflamify.jl. Right. Okay. Let's go into vi fractalflame.jl. So essentially I have a function called flame, which we have ranges, we have a gamma correction, we have an affine transformation, we have file name.check. Can I just, where do I set the functions that we use? So if chose, oh no. Int ranges, resolution, do affine. I'm going to run this. I'm just going to see what happens. What's the worst that could happen, right? Fflamify. What do we have here? We have chaos game. We have fractal convolution, rotate polar pixel sum. Flame. All right. Let's just see how this goes. I'm gonna do 1,000, and then we're gonna do -2, 2, and we're gonna do 1,000, 1,000. What does this do? Does it work? I have no idea. Let's just run htop really quick. I have a core being used, so like, you know, surely it's working, right? Like that's the ideal way. That's how you know it's working. If you have a core running, you know your code's running. All right, let's just see what's going on here. It doesn't seem like we're using too much memory, which is fine. We're only using 1,000 points though. This shouldn't take that long. Anyway, let's just see what comes out. And I'm just gonna write a bunch more to-dos of other things that we need to get done. I mean, clearly when I was writing this code before, you know, like I said before, it's research code, you know? Oh. Okay. An error, but that's okay. I know where this error came from. So I need to add in image IO to the manifest. So let's do add image IO. And then we're going to try it again. See what happens. And hopefully it works. Yeah. Oh, again, I'm going to mention this a few times. I'm going to keep mentioning it because I do think it's really important. Hey, Amaris, how are you? If you haven't already, I know I'm so sorry. I feel so bad about mentioning this so many times on this stream, but I'm going to keep mentioning it a few more times. If you haven't already, feel free to check out this new tag idea I had to do with Twitch. Hopefully creating a research tag so we can just encourage more researchers to stream on Twitch and allow people to more easily find researchers on Twitch. Followage, I don't know what that command's supposed to do, Nerfrust. Sorry about that. But hey, I hope you're having a great day. I think it's done. So let's try it one more time. We're just going to run the flamify.flame and see what happens. But yeah, I hope everyone's having a wonderful day, and I hope everyone's doing okay. So, again, the hope is that we can find some way just to get more, like, really, just more research on Twitch. I really do feel like, I mean, I know I'm biased here. I know that, you know, I'm doing open research. I shouldn't be, you know, forcing other people to do that as well. But I do feel like it's something that I want to see in my time, in my lifetime. I want to see open research labs, and not just like, you know, research labs that encourage open access. No. I want like genuinely open labs that do everything out in the open. I'm going to run it one more time just to see if we get the same error messages. It says file IO with build ID blah 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 is missing from the cache. Oh, what is this? Skipping pre-compilation since precompile false is importing PNG files. Precompiling libpng.jl. Let's just see what happens when we run this. And again, guys, if you have any comments, questions, concerns, ideas, anything like that, just let me know. I'm doing my best to answer everything and go through things. I'm going to be streaming every single day, at least for the next 3 weeks. Might not be super long streams every day, but it's gonna be okay. So let's go here to Mirage. Check.png. Ho, look at that. We have something. It's not much, but it's something. All right, so next we're going to do, let's just see what happens if we run this with 10,000 points. So that's 10 times as many points, and see how this goes. That's a beefy computer. It looks beefier than it actually is. I've got like a Ryzen 3700 or something. So, wait, what do I have? Is it a Ryzen? How do I check? Proc, isn't it proc? Control C, proc. I think it's just proc. LSPCU. One second. All right. The CPU. I think I just need to download it. Where's else? Can I just do yay-ss LSP CPU? Okay, where's LSCPU Arch? See what we can find. Oh, I'm an idiot. I'm a complete idiot. Of course, I should have known that as well. There we go. I have it's obviously AMD. I have a... Where is it? Oh, I maybe have to scroll up. Let me just make this bigger really quick. Yeah, there we go. All right, Ryzen 3700. That's what I have. Look, it's not the latest, but it's not bad. Okay, I'm gonna run this for even more points because I didn't like either of those images. Let's do 10 times more points, and let's see what happens. Sorry. So it's a Ryzen 3700, but my GPU is a well, here I'll show you. NVIDIA SMI. So my GPU is a 970. It doesn't even say here, but it's NVIDIA GeForce 970. It's like a super old one. Mirage check.png. Get in there. Come on, babe. Okay. Flamify. I can't believe we need even more points. All right, let's just keep running this. I'm going to run even more points. See what we can do. You can also install ScreenFetch, NeoFetch to get pretty summary of your PC. Yeah, HardTrack KR, thank you so much for following, really appreciate it. Oh, HardTack KR, thank you so much for following, really appreciate it. Just prints in the terminal. I used to, what was it? It was, there was something that I used to have on my desktop that was, it would like just display my computer stats on the desktop itself. Subachan51, thank you so much for following, really appreciate it. Does anyone remember what I'm talking about here? It's like, Conky, that's what it was. Oh yeah, thank you so much, Conky. There were some amazing Conky configurations. Oh, I'm an idiot. What happened? You? Okay. I don't know what happened there. Okay. Conky configurations. That's what happens when you have a Vim-based browser. Man, okay. Let me tell you, for those of you guys who were not a part of the Linux world in, 2005, 2007, I don't know, like 15 years ago, there was this thing, it was called Conky, and basically, let me just go ahead and can I just open the image here? It was this thing right over here that would tell you, your CPU, your RAM, all this kind of stuff. And it would just sit there on your desktop. Was it useful? No, not useful at all. Like, very rarely are you going to just open up your, remove everything off your desktop just to look at the Conky configuration. But man, it was cool. It was super cool. Let me look at this on Google, because there were some really good configurations that were just, man, top of the line. Like this one here, oh man, it's like literally like it's like, you're on a race car or something like that. I still want this. Like somewhere deep in my gut, I'm like, oh, this is amazing. Like, look at this. You can't say that's not amazing. Like, it's so cool. And here's another one that's kind of the same thing, but it's just over on this side. Oh man, good times. Good times. Man, this was, I don't know if you guys realize, but like, this was back in the day. Like, I mean, Guild Wars 2 didn't exist, but like I spent all of my time, like I didn't play games, but man, I compiled wine like the best of them. I would consistently compile and recompile and try to find the best package. I learned so much about how to like use version control back in the days. I genuinely never really played games, but man, I loved this part of the process. Playing neither here nor there, figuring out how to run the game, amazing, super fun, loved it. Oh, SVN, man. SVN was a thing, and it was the worst thing. But it was better than CVS, CSV? No, CVS was what it was. I have an old Conky configuration somewhere. When I was in school, I used to have my desktop on a cube with Compiz. Oh man, the Compiz stuff. Oh, don't even get me started with the Compiz stuff. That was amazing. Let me see if I can find it. Why did this go away? Like, why did people like stop doing this? Probably because X is like, so probably because the X Windows Manager is like this crazy amalgamation of, legacy code from 20 years ago, but still, it was super, it made Linux desktops cool. I had to use SVN a bit during my internship. People started caring about battery life too. It's still kind of around, and there's rich ricing communities. Yeah, so, yeah, ricing is something I wanted to get into as well. But yeah, here it is. That's what I'm looking for. So when you switch desktops, for me, it just kind of goes back and forth, and you see gravitational, electromagnetic, weak nuclear, strong nuclear. But this guy, literally on a cube, and it would rotate. It would rotate to find the next desktop. It's beautiful. Macro Ramesh 6, thank you so much for following. Really appreciate it. Compass was not great for laptops. That's fair. Unicorn has just turned into everyone using i3 gaps or something similar. Right. Don't know that kanji. Kashi. Muzkashi? Compass was quite heavy. Yeah, okay, fair enough, right. But we have compute power now. Why not use it? Like we have the ability. Natsukashi. Natsukashi. What is Natsukashi? Imi nan desu ka? Google Translate. Natsukashi. Natsu. Chotto matte. Yo. Natsukashi. It's detecting French. How is that French? Japanese. There we go. Dear. Nan desu ka? Nani? I guess everything changed to have similar user experiences to other desktops. Right. I mean, to be fair, I made this desktop setup when I was like 15. Like, I just bought my new computer, right? Like, I worked all summer. I got, I was working 40 hours a week for like 8-10 weeks in a row at like $10 an hour or something. So I don't remember how much money I made, but I made enough to buy a laptop at the end. And I used that money to buy, the brand new best computer I could buy at the time, which was unfortunately a Windows Vista computer. And I remember distinctly buying the computer and then immediately being upset about it. Like, just immediately. It wasn't as fast as I wanted, and I just didn't like it. And so I went like to the lunch table, and I just asked my friends. I'm like, look, is there anything I can do to speed up this computer? I just there's something wrong with it. I don't like it. And one of my friends suggested Linux, and I, being the person I was like, okay, let's do Linux. I at the time thought it was like a download more RAM type of thing, just to make your computer faster. I cannot like underestimate. I was a really, really bad computer person. Like, I sucked with computers. I could not do anything with computers. My grandfather was better with computers than I was. And I spent basically 48 hours without sleep installing Arch Linux. And after that was done, I felt like I owned my computer for the first time ever. And it was amazing. And to this day, sure, okay, maybe I'll use other operating systems. I'll use Mac every now and again when I have to for research, and Windows is fine if I need it, but there's just something, it feels like home when I'm using Linux. It feels at home when I have my terminals available. Like, I know what's happening. I understand what this means to have, like this ASCII-Aquarium. I installed this thing. Like, I understand everything that's going on my computer. Not everything, but enough. And it just makes me feel like I feel happy about it, That's why I like Linux. I don't know why I'm talking about Linux now. I'm rambling. Let's go back to the Fractal Flame stuff. Vista, that brings back memories. I remember getting bootleg copies of Project Longhorn and thinking it was cool. Yeah, so to be fair, I did use Vista every now and again to play games like Guild Wars. But then when I found you could play it on Wine, I was like, why would I ever go to Windows again? It then came out, and was a bit of a dumpster fire. Yeah, I heard that as well. I heard that Windows like Longhorn was better than Windows Vista. Flawless Alias, thank you so much for following. Really appreciate it. Amen to that. I get that. I'm being super, I don't know. What was that? Oh, I got something from my MIT email. There was some Longhorn build, which looked amazing. I'm always worried about this type of stuff, right? I'm worried about Windows 11 because there was some weird boot stuff that was going on that made it so they would disallow dual booting with Linux somehow. I'm just tired. I'm tired of fighting this battle. I'm tired of like always saying this is the year of the Linux desktop. I'm tired of all of this, Like, the whole reason I'm a gamer is because I just want Linux to be successful. And it looks to me like the Linux gaming space is the only people that care about the Linux desktop, So, yeah, I'm tired of all these fights that we have to fight for Linux. But at the same time, I feel like I don't have to do that here. I feel like there's equally biased people here, When I say it looked visually, not that it was, not the OS was. Right. Okay. So, what are we going to do? The event is starting outside, so let me take out my headphones really quick. It doesn't sound like they're playing music yet. They might not be playing music for the next 2 hours, so we might be able to get a little bit more software development in before I go crazy. I say, after having a crazy Linux rant for the past 20 minutes. Sorry. I'm super excited for Linux gaming with all the developments around Linux anti-cheat support for Steam Deck. Yeah, I mean, look, I've mentioned this before. I don't play too many games, right? Like, I play Guild Wars. I tried to play Guild Wars 2, but I just couldn't really get into it. I play Digimon World on a emulator every now and again. But I just don't. As much as I want to be into it, I can't get myself into it. But the thing I really like about the Steam Deck is that it is pushing the desktop forward. And, whether I will support Linux gaming and I will support gaming in as much as it supports Linux, it makes it a bigger thing, I like the fact that Linux just works for me. I have all I need. Exactly. I mean, look, we're in an echo chamber here. Like, for every story that we have, or I have, saying that Linux just works for me, there are countless other stories of people saying Linux just didn't work for them. I'd use PCI forwarding to start a Windows VM. Oh no, to be able to get gaming to be less painful. Oh no. But yeah, clearly we're in an echo chamber here. I'm gonna turn off the music because... Okay, let me know if there's if you can hear them speaking and singing in the background. I can mess around with the music. I'm taking off the headphones now on my end because I can't deal with the conflicting music. Oh no, it's starting. I don't know what to do. It's the worst. Okay, we'll put both of them in and let's see how this goes. Okay. Anyway, we're in a bubble. I just want to say that we're in a bubble. I 100% understand that Linux is 2%, 3% of the market share, whatever it is. And as much as I want that number to grow, and I feel like it should grow, I don't know. I really don't. And I'm not the person to fix that. I used to think I could fix it. I used to think if you have a community of people, all of which are pushing towards the same thing, you could definitely, go from where we are now to, where we want to be, which is, but why would I champion Linux if I could... I mean, I don't want to fight this battle anymore, is what I'm trying to say. Linux is what I use. It's what I like. And I'm a huge fanboy for it. But it doesn't necessarily mean it's what I want to work on in the future. Okay, I'm going to turn the music off now. Because they're singing outside. And I can't deal with it. I can't deal with the music conflicting with the song that they're singing there. All right, let me take a look at this this guy. Okay, so here we're kind of sort of getting the image I was expecting, but I think we still need more points. So here's what I'm going to do. I'm going to run it one more time over here with 10 times more points, and I'm going to time it at time and just see how long it takes. Fair enough, when I explain to people that Linux is just an option like any other OS, and explain that I can do what I need to do with Linux, people understand. There are not many questions, and I work with work in a non-IT environment with people that have never used Linux. Right. I mean, I'm kind of the same way. Linux to me is my favorite tool. I love it. I use it all the time. I encourage its use. I mean, everyone I know uses Linux to some extent when they're using supercomputers. Not everyone, but most researchers I know have used Linux in the past, and still continue to use Linux when they're doing supercomputing stuff. I guess my point here is that it's a tool just like any other, and it's important to know how to use that tool. Especially in research, most people will probably touch some sort of Linux device, and it's important to know how to do that. It's why we spend so much time. It's why I spend so much time teaching people HPC and stuff. This reminded me about NVIDIA SMI. What is fractal generating? I don't know. What is fractal generating? I guess I'm going to Google it because I genuinely don't know. Fractal generating. Generating. What is fractal generating? So right now, I'm basically just trying to see how long it takes for me to run this thing right now to generate a semi-decent fractal flame. And then we're going to go back, once we have that time, and figure out how we can improve it. the right tool for the right problem. Yeah, I mean, yeah, that's how it is. Obviously, like, look, I used to work with a bunch of Japanese people when I worked at Oist, and like support for Japanese input in Linux isn't that great. If you want to do something like that, you can also use NVTop. Look at your GPU utilization. Actually, I never use that one. I always use NVIDIA SMI. Like top does for the CPU. Interesting. Yeah, I'll see if I can find that. Do you know what package it's available in? Like where I could find it? Okay, so it does take forever. I'm not sure what's taking so long. I'm not sure if it's taking long in the fractal generation part or if it's taking very long in the image generation part. So let's talk about that right now. So the way this works right now is we have, let me go ahead and close this, move over here. We've kind of two parts to the method. The first part is the generation of the fractal flame. The next part is the writing of the fractal flame to image. Fractal. Okay, so if you look at the code that I'm running right now, I'm running with, I don't even know how many points. 1, 2, 3, 4, 5, 6, 7, 8. 100 million points. So I'm running with 100 million points. 100 points. That is a lot of points. And this needs to turn into a set of pixels, which is 1,000 by 1,000. So it needs to turn into 1,000, or rather a million pixels, right? So the way this happens is you get 1,000 points and they're all scatter plot, and then you just kind of figure out which pixels are being the most used, and you kind of figure out a scale for that and all this kind of stuff. So this process of turning 100 million points into a million pixels takes a while. I'm not entirely sure how to speed this up, but it is something that needs to be sped up. So that's one thing. What do we have here? Nerfrest, try GPU stat, very nice looking tool. Pip install GPU stat. My laptop is NVIDIA Intel hybrid GPU, and holy moly, it is a pain to deal with, but I think NVIDIA SMI will help a lot. Yeah, honestly, all of the like what is it, Bumblebee? What is it? Like, back in the day, there was that whole like switcher between your NVIDIA and Intel GPU that I used to use all the time when I had that as well. Super big pain. I wish it would just work, but I think even in Windows, it doesn't just work, It's its own package, NVTop in Pacman, has relatively few dependencies, but it only works for NVIDIA cards. Yeah, let's see if I can find it. What am I doing with my life? 1 second. Sudo pacman-s NVTop. I've never used it. Let's see what it does. NVTop. Cool. It's actually quite nice. It took me a second to figure out what's happening. So right now we're not using anything with the GPU. So let's see what happens if I do something with the GPU, actually. So we're going to run Julia, and let's do using CUDA. Add CUDA. That's even better. Yeah, I also have integrated Intel and separate NVIDIA. It's still annoying to deal with. Yeah, like honestly, dependencies successfully precompiled. Okay, so now if we do using CUDA, should work. Oh no, don't give me that. How do I not have CUDA working on my machine? In an error, could not load library, Laos artifact. Oh, no such file or directory. What? Okay, let's just try this again. I'm gonna figure out why CUDA is broken. And then we'll go from there. I didn't expect to spend time fixing CUDA today, but this is where we are. NVTop. Julia. I think I just want to do test CUDA. Oh, that's not it. That's not it either. Test CUDA, capital A. Let's see what happens. LVM is broken. Oh, the GPU compiler is broken. Oh, okay. I've integrated Intel separate NVIDIA. It's still annoying to deal with. CUDA's like cheese. How is it like cheese? Apparently LVM errored. Trigger. So how did LVM error? Let me see what we got here. So let me run Julia. Control C. Julia. What version am I on? I'm on version 1.6.3. LLVM errored. Really? Could not load library. Laos artifact. No such file or directory. Oh. I think he's joking about the terrible pronunciation of Gouda around the world. Thanks, Anonymous Share. I appreciate the bit. How to trigger the entirety of the Netherlands. Wait, what's going on here? Gouda like the cheese. Oh, Gouda like, That's pretty good. Okay, apparently LLVM errored. Yeah, so what is the issue here? Could not open shared object file, no such file or directory, sac trace, library generators.jl, failed to precompile. What's going on with LLVM? Let me just do test LLVM. Could not be resolved. Let me do add LLVM. See what happens. Explain jokes are always the best. I mean, honestly. Would be Tom W. Thank you so much for following. Really appreciate it. All right, let's do test LLVM. Looks like Linux equivalent of a missing DLL. Right, but how am I missing LLVM? It's like the fundamental building infrastructure for Julia. Did I maybe like install a later version and it like messed up my dependency somehow? Gouda is Dutch cheese, but it's pronounced more like Gouda, but a lot of English speakers say Gouda or Gouda. Oh. So basically, the joke about Gouda only works for English speakers who are mispronouncing the actual cheese. I mean, honestly, you said the explained jokes are always the best jokes or something like that, but actually, I genuinely feel that's kind of true. Like, the act of explaining a joke is just always funny to me. I really genuinely like it because it's like, yeah, okay, obviously like a joke that everyone laughs at, yeah, that's one thing. But like the explanation of the joke when everyone's like, okay, it's just such a funny thing. It's just like that one little awkward, like, okay, I gotcha, I understand now. But man, it took a while to get there. There's something funny about that I love. Okay, so what are we going to do here? Could not load library, Leos artifact, dependencies precompiled in 1 second. To see full report, import package, precompile. Okay. What if I just do precompile? LLVM is broken. This doesn't help me in any way, shape, or form. Let me see if I can figure this out. Sometimes this is just as simple as turning it off and on again. We'll see. It took 368 seconds, which is a total of 6 minutes about, to run that code. We want to get that down to millisecond range if we can. So, right, that's 6 order of magnitude improvement. I don't know if we can do that, but we're gonna have to try. Right, so let's see if we can figure out the LLVM stuff and go from there. Right pronunciation, but right, most use the English G for the first letter. Oh, Auda. Oh, you don't even pronounce the G. In French, it basically sounds like Gouda, but we pronounce it Cuda. Let me see, what do we have? Oh, in French, it basically sounds like, let's see what we got. Where are we here? Open up a new tab, paste this in there. Gouda. Sure, I agree.
Gouda.
Oh.
Gouda.
Fouda.
Gouda.
Gouda. Gouda. Interesting. Okay. Should I just what if I run Julia? What do I have here? I have Julia 1.6. What happens if I run 1.6? And then I run using CUDA. Is this going to build? Because maybe I just run with Julia 1.6. Screw it. 1.6.4 is for chumps. Give it a second to precompile. I'm pulling my hair. Julia indexing is weird. Okay, so your pull request. So the fact that it's indexing by 1 might mess things up a little bit. But if you're running into issues, I think a silent tree, what's his name on GitHub? Their name on GitHub. It's what is their name on GitHub? A silent tree / let me check. Has also done it. Algorithm archivists, algorithm archive here. And then we want to go to pull requests. Storm of Ice, right? So Storm of Ice, a silent tree, has done it with C++. Oh, okay. So I can actually use LLVM and CUDA and everything with Julia 1.6. Just for some reason, Julia 1.6.4 didn't work. Okay, so now what I'm going to do is mess around a little bit. I'm going to do Control D and NV top, and I just want to do something. I think this is going to be cool. I don't know, but I think. Okay. I'm going to do A is equal to rand. No. A is equal to coup array of rand of 1000, 1000. What does that do? Give it a second. Does my memory increase? I'm downloading CUDA. My gosh. Give me a second. And their name is the same. Hema is slightly hard. H. Oh my gosh. The music outside is killing me. I know you guys can't hear it. And I'm so sorry. But like, it's so hard. Like when the music has like a, they're clapping. They're clapping too. It's right outside my door. There's like someone singing and they're going, wait. Oh man. And they're clapping. It's the worst. It's actually not so bad. It's like the worst. I just can't. I wonder if I'm disrupting them. Like, I feel like I must be disrupting them, right? Has to be. Does my memory increase? Downloading new memory? I thought you were going to say. Okay. Look. Did you see the blip? Did you see the blip? No, it's not. Okay, for the record, you're right. Oh no, people having fun. I'm kind of joking. Obviously, I'm joking a bit. But it's just between the input of them speaking and I'm quite quiet. I'm quite quiet right now. They can't hear me. But just between them, like outside, and me in here, I'm like worried I'm interrupting them, you know? Okay, so cool. Okay, NVTop works. That was that's what I learned from that. Okay, so we're going to control C over here, and we're going to control D over there. Okay, and the fractal flame method takes around 368 seconds. So I don't know where I want to put all my to-dos, but I think I should put them in like a general notes directory. So let's do that. CD notes, ls here. Notes.txt. What do we have? Heart function does not seem to work. Need to properly implement affine transforms before and after. I don't know what these notes are for. I'm going to delete them. Clearly, that's what you do. If you don't understand what's happening, you just delete the notes and yeah, pretend that they're working. Okay, so I think one thing that we have to do is decrease time. A broken heart? I mean, it clearly seems that the heart function is working, right? Like it has this. So, right, the way this works right now is that each function has itself like a color associated with it. So like the heart function has a pink color and like the swirl function has a blue color and stuff like that. That's why this has like a pink outline and then a blue interior and stuff like that. So I think what we want to weigh is to revamp the, I guess, UI a bit. And we want to make sure that we can do the following. We want to make sure that we can define what color each function, which color is associated with each function. 1 second. And then B, we want to probably just use some sort of symbolic utilities to do this. So let's just think about Impero for that. So revamping the UI is one thing that we definitely need to do. Another thing we need to do is lower the runtime. The question is, obviously, one big part here is the GPU, GPUization, parallelization via GPU. But another thing that we have to do here is, 1 second, I'm thinking. Another thing we have to do here is outputting. Okay, with the parallelization to the GPU, what units can I use here? This? We need to consider. I'm thinking. Oh, it's hard to think. We need to do a couple different parts. Let me just put this in B. So with lowering the runtime, outputting to file. To file. All right. These are just things I'm thinking about right now. Let me catch up on chat here. a broken heart. I wonder how they do a Mandelbrot zoom to a zoom factor of 10 e to the 2011. Must need forever because they can't use normal floating point numbers. Hey, Lightbook, how are you? Hope you're having a great day. It's been a while, but yeah, I hope you're having a great day. Is it possible to zoom into the flame fractal too? Not exactly the same way, but as far as those fractals are concerned, we actually used to do a bunch of those fractal zoom things. Let me see if I can find any. CD Projekt Simuleos, fractal, LS here. What do we have? Do we have a fractal zoom already up? I don't know. Fractal zoom plot.gp. CD animation, LS here. Chaos of CPP? I don't know, but we used to have these zoom plots. And the answer is that every time you zoom forward, you're not thinking so much about... Essentially, every time you're zooming in, you're replotting a new distribution every time. And essentially what you have to do is every time you like go a little step further, you just create a new distribution that has slightly smaller, just... Instead of looking at a camera this far and you go in. Does that make sense? And you just replot every time. And then what you do is you renormalize, right? To make it so that the color bar, isn't getting darker and darker as you go further in, because you're essentially going into like a very dark part of the plot. It's actually not too tricky to do. As far as zooming into a fractal flame is concerned, the answer is technically yes, you can do it, but because you're not plotting the full domain in the same way, you can't just you don't have some complex domain that you're plotting. You're plotting a bunch of individual points. And because you're plotting a bunch of individual points, as you go further and further, you're eventually going to hit a part where there isn't a deeper level until you redo the entire distribution. And like you just saw, each distribution takes a few minutes to generate. So in some sense, it's just slow, right? You don't necessarily want to do that. Man, I'm terrified that, I don't know, we'll see what's happening. Anyway, good. So I'm just going to write down a bunch of notes of things that I have in my head as we're going through this. So let's CD projects at Flamify, CD notes. All right. Alice here, VI notes.txt. Okay. So these are things that I've been thinking about right now. So revamping the UI, lowering the runtime, and then the next thing is modularity. So this basically means that we want to be able to plug and play different IFS systems. To A star. Yeah, that's not the best system, but it's what I tried. Let me get some water. Okay, we've got a few more people here. Now, I'm going to say the same thing that I said earlier. I'm just kind of watching the viewership, seeing when more people come in. I am trying to get a research tag as something people can stream under on Twitch. So here, if you haven't already, I know I've mentioned this 4 times on stream so far, and I've only been streaming for 2 hours. So I'm sorry, but I'm really trying to get the research tag as as something going on Twitch. I just want people to be able to click on the tag and find other people who are doing research on Twitch, because I think it's really important. And I think a lot of researchers would love to stream on Twitch. I think it's a great place to do open research, but it's just not how things are going, Which Windows manager is this? I'm currently using OpenBox. And I have a custom theme, which you can find on Discord. Here, I'll go ahead and give you guys the link right now. Here, I think if I do this, it'll give it to you. Add an invite link, make sure there's no limit. Sure, expires after 7 days, seems fine. Edit. Paste, grab this guy, paste. There we go. Let's see, what do we have here? No, close that. And if you're looking for the actual theme I use, it should be pinned in off topic. So here it is right here. It's grayscale.tar.gz. If you're interested in using it, feel free. Just want to let you know it's there. What do we have here? MadFlash19, thank you so much for following. Really appreciate it. It's already in Science and Technology together with the duck streams. Wait, is it? What is it? Wait, maybe I'm misunderstanding something here. Twitch here. That's not what I wanted. That's also not what I wanted. Let me go to Twitch TV. Let me check really quick. Okay. Oh, I'm talking. I'm so sorry. Doing a really bad job here. Following, delete that tab. Categories. I'm following Digimon World. Everyone knows that now. Science and tech. Close that. So if I look for research here, I'll find it. Because maybe I'm completely wrong. No, just retro. There was a lot that happened there. That shouldn't have happened, but it happened. Yeah, I don't think there's a specific research tag for people to be under. The next thing I want to do, not tag, only category. Right. So I do believe genuinely that the science and tech category should probably be the category for researchers, but that's just not what it is right now, you know? At least programming is now under software and game development. Right, but I mean, we've actually mentioned this before on stream a few times, right? Like I'm doing a lot of software development. Well, I'm doing a lot of programming, but it's hard to call what I do software development, and it's certainly not game development. So that's why I'm still streaming under science and tech, because in the end, I am trying to do more like research projects, right? So I believe science and tech is where that belongs. But like that's also like one of those things. In theory, I feel like that's where it belongs, but in practice, maybe all the viewers are under software and game development. Maybe what Twitch did is it created a science and tech category, and then all the scientists went to just chatting because, frankly, the category was filled with game developers, and then all the game developers went to the software and game development section. So now the science and tech category is just a husk of what it's supposed to be. I don't know. Point is, I want to see more researchers on Twitch, and I'm trying to figure out how to get there. So let's go ahead and figure out what else there is to do here, because there's a lot of little things that we have to get done. I keep getting all these messages from like the Japanese government telling me that Barcelona is like under siege by coronavirus right now, and that like I should stay away from like large city centers as much as possible. I can't really do anything about that. Okay, so as far as this is concerned, I'm trying to look through this and think about things that we need to consider. So it would be great to see more researchers here. Yeah, honestly, I would love to see like a just general category on Twitch where like you can see a physicist doing stuff with a laser. You can see a biologist like looking at things under a microscope. You could see, a computational scientist like doing large discrete or large density functional theory stuff. Like I'd love to see that, honestly, but it's just not what we have right now. As much as I'd love to see it, I know it's going to be really hard to get from where we are to where we want to go, and I really don't know how to get from here to there. I'm on board with research tag. Yeah. So anyway, if you guys are interested, please fill it out. Look, it's going to be hard to get as much support as we need for Twitch to actually turn their head and think about this. But if we could get Twitch to think about it, that'd be great. I'd love to see that, I'm curious to hear how, like, how loud is it outside? Can you like hear, like, okay, I think because I've got my, my condenser on or whatever, like, I don't think you can hear it too loudly, but it's certainly loud. It's certainly loud enough. It's like louder than I am, like right now when I'm talking. So you'd think it'd be like, I don't know. I'm just wondering if you guys can hear it. Okay. So we have the idea of the different functions. We have the idea of the different colors that need to be extended to the different functions. Seems fine. Only when you talk. Yeah, that's it. So the way I have it set right now is I have this thing. Oh, 1 second. Let me go to, not what I meant to do. Let me go here. Let me go here. And then let me do file, open. Yeah, that's what's happening. Yeah. Not that bad. Sounds much quieter than you. Yeah, so what's happening is I basically make it so any lower values, like they don't trigger the, they don't trigger the like microphone at all. Anything down here doesn't trigger the microphone. So the only time you're going to hear them is when I'm talking, and then it sounds as background noise when I'm talking, because then it triggers the microphone, if that makes sense. I do this just to cut down on like background noise when I'm not talking. And it clearly works because you couldn't hear that just then for a second. So I don't know. It's weird. Okay, let's just keep going. Let's just keep going. Okay. I'm right now trying to create a list of things that we need to get done. So let's go back over here. So we need to revamp the UI and essentially use the symbolic utils that we were talking about yesterday and the day before to make it slightly easier to use. We then need to lower the runtime. This is going to be predominantly done with parallelization via the GPU, but we also want to make sure that's modular, so we can plug and play different iterative function system solvers. So like different chaos game solvers, all this kind of stuff. I'm wondering if I should tell my wife that it's quite loud. Maybe she should stay in the office. I don't really know how much longer they're going to go. They started at 5:30. Anyway, I can't do anything super intense right now, but I can probably, I can at least write down a list of things to get done, and I think that's still a very good direction forward. Okay. So in this outputting to file, what I need to do here is I need to basically revamp all of the image tools. So revamp all the image tools. And I don't actually know how to do this, right? Because if we're outputting to file, can we actually use the GPU to help with that parallelization? I don't know. So the question is, should we be outputting to file? Or should we be maybe looking at other tools? Like, can we do like, maybe like OpenGL libraries? Maybe? To like write it, like, you know what I'm trying to say? Like, is there a way to just open up, let's just see what we can find. OpenGL. Surely, there's something we can do with OpenGL and Julia. Julia GL. Let's see what we have. GL Visualize.js. Ooh, these are old, aren't they? GL Visualize has been replaced by Maki a long time ago. Ooh. I don't know if we want to use these, but maybe there's a way to use Maki, right? So if you guys don't know, Maki Julia, this is a visualization tool. Here we are. That I think we might actually be able to use for this purpose. It uses OpenGL underneath. It's meant to do things in real time. Maybe this is what we should do. Maybe we look up Maki for this. In general, I haven't really liked using Maki in the past. Not that it's bad, I just haven't really gotten into it. Are you continuously writing to file? You could do that at the end. Oh, we're not continuously writing to file. We're definitely doing it at the end. The difficult part here is creating the set of pixels to write to file. That's the part that takes forever, because we're taking 100 million, a billion points, however many points that we're taking, and we are turning that into a certain set of pixels that are way smaller than a billion, right? So 100, 1,000 times smaller. And so we have to go through each pixel and we have to figure out how many times a point, falls into that pixel. It's not a straightforward thing to do, especially not in serial. We might find a way to parallelize that process, actually. In fact, you've just convinced me. I think there is a way to parallelize that process. So if we can find a way to parallelize the binning, that'd be nice. I think actually we can do that on the GPU, because it's not the file I/O that's taking so long. It's the creation of the array that we write out that takes a while. Good point. Thanks for that. Okay, so let's do. Let me take a look at some image tools in here. Oh, actually, other thing that we need to mention here is Fractal Flame stuff. So here, like I mentioned before, we never actually did any of the motion blur. What do you guys think? So let me open up the file for for the Fractal Flame method. So we're going to do ocular, and we're going to do draves. Where are we? Chotomate ls flame draves. Ocular flame draves.pdf. Okay. So the only bits of this paper that we haven't implemented are the motion blur bits down here. The motion blur is specifically for moving fractals. So like if you have a fractal that goes from, do they even have it in here? I guess something like this. Oh, I actually don't even know the difference. So one is motion blur and the other is directional motion blur. And I don't really see the difference here. But the motion blur is like the last bit that we didn't actually implement. I think we have everything else here. because I think filtering was just a convolution. And then I think the motion blur is what we don't have. So, do you guys feel that we need the motion blur to call this a fractal flame? That's my question. And I don't know the answer to that. And that's something we have to figure out. So let's see, what do we have here? I'm going to scroll up to the top. What is this plot for again? Plot showing that the distribution of densities in an iterated function system follow the power law. Oh, that doesn't help at all. Completely useless. Okay. So the reason I'm arguing we might not need the motion blur in the end is that, first of all, motion blur only works for moving images, right? So that means we need the images to change with time. But the other thing is that almost everything past this point, wait one second, is a post-transformation, right? So 3.1, 3.2, actually, wait. Anything past 4, the log density display, the coloring, all this kind of stuff. All of that is like stuff you do after the flame method is done. So I think if we're specifically creating one image, and also we're going to be using this for fractal compression, I think the idea of creating motion, of having motion blur isn't necessarily, I don't know. Okay, well let's actually just read through the motion blur section and see if we can figure it out. So let's think about what we need to do to change the code so that we could actually have motion blur in there. So we're going to do zernal pp, and we're going to do flame draves.pdf. And I'm going to make this here. Perfect. Zoom in a little bit. Something like that should be fine. And scroll down and let's talk about the motion blur a bit. Let me get some more water as well. Symmetry. Oh, symmetry. We never did symmetry either. Okay, so maybe... So symmetry in here. What is symmetry? So symmetry is the act of, like, taking an image that looks like this guy and turning it into this guy, or this guy. And essentially like using symmetry across different axes, like XY symmetry, or symmetry along the Y-axis, symmetry along the X-axis to create different plots. Do we need that for our purposes? No, because we're going to be doing fractal compression with this. And fractal compression, like these are just ways to make the image prettier, whereas the other stuff with the filtering and all that was useful to make the image better. And I think the discussion will be that we can skip the symmetry argument and we can skip the motion blur argument because we're focused on making images good, not focused on making images pretty, right? So we want the highest quality image out. So I think we're going to skip those. However, the argument is for the algorithm archive. For the algorithm archive, when we're talking about the fractal flame method, do we need to introduce these? I guess maybe we do, right? I mean, they're in the original paper. We probably should talk about them, right? But I could also just say, go to the original paper for this discussion. And if you actually want me to talk about it, I can add it in the algorithm archive when you want it, right? So maybe that's what I do. Okay. It would be great. It would be great if you could talk about how you read research papers for someone who never did. I would want to start doing that since I study AI, but research papers confuse me. Yeah, that's a good point. Let me get some water and we'll talk about that as well. Okay. Right. So how to read papers. This paper isn't necessarily the best example of a good paper to read, but in general, papers are considered or have like, a couple distinct parts. At the very start, they have a title, obviously, followed by, people who made the paper, Scott Draves and Eric Rickhouse or whatever. And then after that, they have something called an abstract. Now, at this stage, you probably aren't reading the paper yet. You're trying to find the paper to read. And so you've probably already read all this before choosing the paper that you want to read. Then they have the overview, followed by, literature search, a literature review, kind of like a discussion of what they're talking about, i.e. iterated function systems. And then they talk about methods and like how you'd actually get the implementation done. Typically, when you're reading research papers, you read them like you'd read Wikipedia articles, right? So you go through and you basically keep reading until you find, a word that you don't understand. So here, a two-dimensional iterated function system. It's like, maybe I don't know what an iterated function system is. So you can keep reading on this paper, but know that probably in order to understand the whole argument, you probably need to understand this thing. So what you're going to do is you get to this point, you find something you don't know, and then you figure out what that is you don't know, and then come back to the paper later, right? So the act of learning or reading a paper, you don't think of it like reading a book or watching television or watching a YouTube video. Think of it more like reading Wikipedia, where you're trying to fully understand a topic, so you've got to kind of go down all of these rabbit holes until you eventually can come back to the paper that you were reading with a better understanding and a better set of tools to understand that paper. I don't know if that's super helpful or not. I really don't know the best advice to give here. The other thing to say is the more you read research papers, the easier it is to understand papers, right? It's like anything. Like, if you're trying to get someone into your favorite video game, right? Like, you always make the argument. It's like, the end game is really good, right? Like, you don't usually make the argument that, like, let's say I'm trying to get someone into Guild Wars, right? Like, the reason I love Guild Wars is that it has a huge, crazy skill system, and there's all these amazing things you can do once you understand it. And the same thing is true for research papers. Like, once you understand, how to read them and how to use them, all of a sudden you have this huge, vast array of tools that you can use, all these amazing skills that you didn't have before. But you have to get there, and the only way to get there is by reading papers. So what I would recommend is, if you're trying to learn a particular topic, first, just try reading the paper. If you can't, and you have to circle a lot of these words, go try to read all those words. But also, there could be what's known as a review article available on the topic. So if I'm trying to read iterated function systems, chances are there's a good review article on that, which is meant to be at a slightly more general audience, so that it's easier to read by a broader group of people who are trying to get into the topic for the first time. So it's closer to a textbook chapter than it is anything else. And so, I don't know. That's my advice. My advice is to treat it more like a puzzle than a book. Try to make sure you understand all of the little pieces of the puzzle that come together, and then go from there. Core, abstract, results, conclusions, the rest of it. That's the way I used to read them. Drop as soon as possible to get the relevant ones more quickly. That's true as well. If you have to go through a lot of different papers, like a lot of times if you're just learning the topic, the most important part is going to be the literature review section and the results and conclusion. That's the most important part. If you already know the field, you can usually stop looking at the literature review section and only look at the results and conclusion. If you're trying to replicate the results of the paper, then the most important part is the methodology. And I know a lot of experimentalists who exclusively only look at the methodology of the paper because that's the part that matters. That's the part that will, help you, that's the part that will help you ensure that the paper is actually of decent quality, right? And so that's kind of the, basically the more you read, the better strategies you'll find to do it. And so my stupid, naive answer to that question is the easiest way to read research papers is just to read research papers. And I know that sounds stupid, but know that what I mean when I say that is that, it's gonna, no matter how you enter the academic, literature, world, it's going to feel like you're banging your head against a wall, right? And so you just got to burst through that wall and figure out, the best way to do it. For me in particular, I find them super enjoyable. Like I said before, I love reading papers more than I do, watching YouTube videos or movies or anything really. Like, papers are like the number one way I actually like pass the time. I find it really enjoyable, but that's not true for everyone, So anyway, it's kind of neither here nor there. It depends on how you want to do it. I'm so sorry that was super rambly and it didn't really give you a good answer, but I hope maybe it helped somehow, But yeah, the structure of the paper, depending on how you want to get through it, you can approach it in different ways, So, okay. So, I'm struggling a bit with these people outside. Again, the people are not bad. Like, they're fine. It's just that they're outside and it's distracting. That's it. Like, I need to be very clear. Like, I'm happy that they're enjoying themselves. Okay. So, I think then we kind of have an idea of how to attack this. And we kind of have an idea of what we need to do next, which is going to be implementing our UI elements that we created before into the Flameify package. And then after that, we need to modularize what we have so it allows for different iterated function system solvers. And so I think that's a good list of things that we need to get done. We have the code running. We know that we need to drop it down by like several orders of magnitude in terms of runtime before we're happy with the results. I think this might be a good place to just say, okay, we've got a list of everything we need to do. Let's tackle it tomorrow. I know that's super unfortunate that we can't tackle it today. That's in part because I started late, and in part because I'm very flustered with the people being outside. But we did make a lot of progress today. Just for the record, I think we made a lot of progress. Like the planning stage of every project is always one of the hardest projects. Mr. Anderson, OX, thank you so much for following. So, if you would allow me, I think I'm going to go ahead and close stream now, and we're going to come back tomorrow and hopefully do a much longer stream. Tomorrow is a holiday. My wife is probably going to be here, so I'm definitely going to stream. It might not be for super long, but I will definitely stream. It might only be for 2 hours again, but I will definitely stream. Atish Sai, thank you so much for following. Really appreciate it. And we're just going to knock it out. We're just going to start programming, get the stuff that we did earlier with the symbolic solver into the Flameify package, start implementing a bunch of different fractal flames, and just try to get this thing working. And hopefully by the end of the day tomorrow, we have a really nice UI for just like creating fractal flames. And then we'll start to kind of work on the chaos game solver and make that parallelized and stuff. We'll be on the same time tomorrow. Yeah, definitely the same time now, but I might start way earlier. So my hope is to start so it's currently 6:30 p.m. my time, but I might start as early as 1 or 2 o'clock p.m., and I'm going to go for as long as 8 o'clock p.m. So this time zone, I'll definitely be live. And I'm really going to try to just do a long stream tomorrow and just work through it. This might or might not mean that I have to bring back the Swole Laos workout program, which means that I might have to do like a workout on the top of the hour, just a quick 20 squats or something like that at the top of every hour to keep myself motivated, but we'll get there. Yeah, I'm in Barcelona right now. Pisoto, thank you so much for following. Really appreciate it. Okay, so let's see who's live and who we want to raid at the end of stream. Where is stream? Oh, it's here somewhere. 1 second. Let me just go to stream. I don't know which tab it is. Okay, so Lana Lux, Tim is live. We could raid Tim. Man, I've actually, okay, so here's the thing. I haven't streamed in a while, and I haven't really been entertaining myself online for the past year or two because I've just been super busy with other things. I haven't had time to like watch videos or watch streams. Do you have anybody that you want to raid at the end of stream today? Please give me suggestions, because quite frankly, I don't know who is good to raid anymore. Like I only have a few people live every time I want to end stream, and so I don't know who's live during this time zone who we can run into at the end of stream. So if you guys have somebody that you want to raid, let me know and I'll go ahead and do that. Otherwise we'll raid Tim or something like that. But yeah, I'm hoping that we can kind of like slowly but surely dig ourselves out of the hole that we've dug ourselves into. And so off the stream today, I'm gonna spend some time. I'm gonna spend some time just figuring out how all the pieces of the puzzle come together. Let me get some water. Ooh, it's loud. I need to figure out also how long this is gonna take, how long the event is gonna be. So to see if I can actually get some sleep tonight or not. But we'll see, because honestly, there was a band that was playing until 3 o'clock in the morning in the square nearby our house, and it was insane. I just don't understand really, but that's okay. I'm not Spanish, so what do I know? Or Catalan. Okay, so let's go ahead and raid Tim then, because I didn't see anyone suggesting anyone in the chat, so we'll go ahead and do that. So we're going to raid. 1 second. Tim, Beaudet. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos, where we'll just knock stuff out. Hopefully get a full symbolic solver in for the fractal flame method and just go. That's the plan. Thanks guys again, and I'll see you next time. Bye guys. Wait 1 second. Okay. Yep. I'll see you later. Bye, guys.